So today I'm going to be chatting to you guys about unified red team automation. So not so much automating the actual job, because as far as I'm concerned, that's still always going to be done by people, but we're going to be mainly looking at the infrastructure side of things and trying to kind of utilize and collate as much information into a single portal as we can. So yeah, I'm going to kind of walk you through it. The second half of the talk is all demo and live demo, so wish me luck, but we'll see how we get on. So who am I? I'm Don Mortimer. I'm a red team specialist at Bulletproof. I've been red teaming pen testing now for probably the last nearly 5 years, with the last kind of 3 years of that pretty much solid in red teaming. Before that, I was a sysadmin, so automating things and basically taking the laziest way out of stuff is pretty much how I learn IT. You'll probably see me around Discord as either like Czar. I think I'm on Twitter at DSEC or some variation of it. So yeah, feel free to grab me for a chat. So we're just going to have a quick look at kind of what this is, what I'm going to be talking about, and the portal I've designed to do it. What I viewed as the current challenges and what was annoying me or frustrating me in terms of deploying infrastructure in a quick way, getting information from it, and sharing it between multiple resources. And then we'll look at the general approach I kind of took, so with a big caveat of that I am not a dev in any way, shape, or form, so I've probably done some really stupid design choices, but it works. So we'll then pick up with a kind of demo, and I'll run through building some infrastructure, show what it looks like, and then show the additional features of bringing information together within kind of a single portal that I've done. And then I'll discuss the kind of future plans and releases and things that are coming, stuff that you guys can actually get involved with. So, yeah, as I mentioned, it's a look into the approaches used to simplify and centralize the deployment and management of infrastructure, and now probably considerably more, starting to add in sort of more and more features. And this is achieved using a web-based tool that I've called Red Commander. So it's all based on open source kind of, well, Django platform, and we'll have a kind of sneak peek into all of that. So the current challenges I kind of identified and things I didn't like with how I was deploying infrastructure currently was there's tons of open source, multiple open source sort of CI/CD and CLI based Terraform, Ansible deployment tools. And they all require lots of like heavy customization. You're constantly adding the same IPs. You're having one operator deploying resources completely independently from everyone else. You have no visibility across your different resources. And some of these are quite out of date, or they're really overly complex and use new Ansible roles, new functionality that is quickly depreciated or moved on, and APIs change, so you're constantly having to repair things. So I was like, right, I'm going to try and keep it as simple as possible, take out all the room for errors, and design something suitable. As I mentioned, managing and deploying infrastructure across multiple cloud providers and systems is also a bit of a pain. You know, these days we kind of utilize any cloud system or cloud platform we can, be that from deploying VMs and infrastructure to the network side of things. So being flexible to go anywhere and put things anywhere we can, then that's kind of what we want to be doing. Likewise, from a management perspective, as kind of a lead, tracking infrastructure in terms of costing, project assignment, and life cycles when you're using multiple platforms, again, is a pain. And as a small team, you know, there's only 2 to 4 of us really focusing on red teaming, so the more we can optimize our features and or like our functionality and make things as streamlined as possible, the better. And if I can keep an eye on the bottom line, costing, where things are, great. So they were the kind of what I identified as the challenges. And with that in mind, I started, this is like the 5th time everyone's seen this meme, I think, today, or like yesterday. But I started to kind of identify things that my platform must have to try and address those kind of issues. So easy to manage, so that's why I ended up going kind of the web route. I wanted to move away from CLI and config files and constantly having to change and add things. You know, we use other platforms like we used OST, and that kind of single pane, single area you go to and just clicking, navigating, generating what you need to was perfect. Secure, obviously with CI/CD and Terraform, Ansible, you're storing a lot of secrets, you're accessing data. So, you know, trying to design a platform in the most secure way possible, probably not me the best at, not being a full web dev, but you know, I tried to take best steps to minimize like disclosure of secrets, only using them during runtime, encrypted storage, etc. Also making use of modern infrastructure approaches. There's not been a massive change in terms of deploying red team infrastructure since like the kind of blue screen of Jeff days. So doing this has been interesting, and like we've touched on some of the key technologies I look to use, like Ansible, Terraform, and Tailscale. So Tailscale I'm probably going to bang on about a lot today, but it's really been a kind of a unifying technology to allow us to do what we need to. It must support at least Azure and AWS. So from our point of view, AWS is our core provider. Most of our infrastructure goes in there. Azure is a secondary, and that's kind of how it's got to work as a minimum. API-driven as well, so everything within the web portal needs to be API-driven. I want to be able to slot it in anywhere and have projects spun up and designed by your upstream sales pipelines to automatically generate and spin up resources. So APIs are key. And a modular design that even someone like me can quickly add new functionality to. You don't need to be an absolute expert in Terraform, Ansible. You can just plop in new features, new functions, new playbooks, and it will just work. And also, like I said, which is kind of the end goal, is to start unifying as many data sources from an engagement into a single area. So as an operator, as a lead, you can see everything that's going on across your organization, across your teams, across the multiple jobs you've got going on, and even now I'm starting to ingest things like, C2 logs, parsing, and eventually look to introduce AI or learning models into further kind of digging into that data and providing insight. So, as I mentioned, the kind of core technologies I'm looking at, Tailscale is like the beating heart of everything. It makes things so easy to tie everything together, and that's what's really changed probably over the last couple of years with using that over previous red team deployments. You can have multiple resources in different providers, unify it all over a secure backend network, and communication is easy. There's no port forwarding, there's no on-demand SSH tunnels spun up, public ports being available. There's no excuse for that kind of stuff these days. You can just do it all over Tailscale. Django was something I kind of got to know a bit with tools like Ghostwriter, which you'll probably see when you see the platform, where I've taken some of the inspiration and kind of like the project-driven approach. And that I use as a kind of a basis. The one thing I hated about Django was its API framework, but Ninja API has come along recently, and it's basically fast API, but for Django, and integrates with all of that. And even for a mug like me, it's quite easy. Mailgun as well, we use that for all of our mail notifications. The platform hooks into things like Teams, Slack, Discord, to kind of keep operators up to date as things move through different stages. CloudFront, again, we use for automatic site generation and things like domain aging and like aging them out, making things look legitimate. AWS, again, as I mentioned, our core provider, Azure, Ansible, and Terraform. So everyone's probably familiar with lots of those things, and I haven't done too much sort of reinventing the wheel in terms of use of Terraform and Ansible. I've just kind of tarted it up and made it look pretty. So the core design concept, as I mentioned, hasn't really changed. We're looking at deploying kind of private VPC groups per project. Each group is individual and self-contained. So, for example, the internet-facing security groups and the private security groups can't talk to each other over AWS. All traffic goes over the back-end tail network. And this lockdown of communication is just really, really useful. So we can do exactly the same and have all of these resources within Azure, within GCP, or anywhere, and the network layout and architecture still stays exactly the same. It doesn't matter where they're placed. The overlaying like architecture and control, again, which I'll talk about further on, around Telnet ACLs, again, gives us lots of control. So where the resources can't directly talk to each other within the cloud platform, we can have them locked down. So, for example, Project VPC1 and Project VPC2 can't talk to each other at all in either of the resources within Azure. They also can't talk between projects over Tailscale, but as an operator, you can come in and talk to all projects and to your core networks, and your core networks can talk to everywhere. So with ACL taggings within Tailscale, we can create like really dynamic networks across all different resources, easy peasy. Like, it's no problem, it doesn't matter. And the API for things like Tailscale and management, again, easy to plug into, add to the platform. We can just deploy resources, tag it on the fly, and it's ready to go. So, yeah, tried and tested, probably not unfamiliar with the kind of basic layout of how the red team sort of infrastructure looks. The bonus as well with approach is we can add as many resources to a project as we want. So anything from a simple penetration test or phishing assessment, you can have a single GoFish server deployed, for example, or you can have 30 C2 servers. It's entirely up to you. As I mentioned, we use kind of Tailscale access controls. So we have operator devices, core network devices, and then project systems. So project systems are dynamically created every time you add a new project and prepare a resource. And then operator devices are automatically joined when someone or a new person joins the Tailscale network and adds their own device to it. Operator devices can access all areas of the network, but cannot talk to each other to prevent people from playing around with each other's devices. Project devices cannot talk to other project devices, but can talk to each other, so it's easy to share things like backend network traffic over things like Red Elk and all other services, C2 servers, for example. The other thing we use is ephemeral keying or ephemeral tagging within Tailscale. So once a node goes down for a period of time, I think it's like half an hour to an hour, depending how often it refreshes. It used to be much slower, now it's much quicker. The nodes are automatically removed, so we don't need to add in any other extra logic to remove these from the tailnet. Once they're powered down and removed, they're gone. So these kind of fundamental technologies within Tailscale have made things considerably easier. There's also additional features which I haven't really touched on, such as Tailscale provides the ability to SSH directly into hosts using Tailscale. We can also use back-end certificate generation, so it uses Let's Encrypt, for example, on the back end to generate accepted certificates within a private network. So we never have to expose DNS records or anything else. We can just create private back-end Let's Encrypt certificates for things like Red Elk, and it all just works. We get secure back-end comms all within our controlled network. There are open source alternatives for the keying server and authentication server for Tailscale. So if you're in controlled environments and you have to have control of your own network access and things like that and don't want to rely on Tailscale as a company to do it, you can do it in an open source way. You just have to host your own server. So something to bear in mind. And as for the actual platform itself, as I mentioned, it's a posh way of doing stupid things quickly. So it basically does lots of moving around of templates. So as long as you put things in the right area, you follow the correct naming conventions, the portal will pick up what you're doing and move things into the correct area. So if we go through an initial request for new infrastructure here, you'll submit a build request to the API, which is pushed through from the front end, so it will automatically pull things through your project ID and project information and any other fields you need to pass between the database. It's one of the reasons I chose Django, because the relationship database setup on it is so easy. Again, I can do it, so it can't be that difficult. The statuses as well are also tagged along on the back end to send updates and notifications and also to limit certain features and functions kicking in at different times. DNS records and DNS zone management is also included in the platform. At the moment, it only supports Route 53, but it gives you the complete ability to track domains and also assign them to resources as you build them on the fly. So once that's done, effectively, it takes all that information, including the modules. So say, for example, we're building a team server. It will fire it through, build a unique project location where it's going to hold all of that Terraform information, populate those templates with the required bits of information. The bonus with this is you can use templates and variables in areas that Terraform doesn't usually let you use. So because we use Ginger on the back end just to move those templates around and render them with the database information, we can set variables, name things quickly and easily without having to rely on Terraform variables. So we can name things differently, get away with a bit more than Terraform natively would allow. Also, one of the things I designed in through the whole, process is often I'll screw something up, or I want to join or jump into a particular stage in the process and do something manually, be it a quick to change to a template or how I want to deploy something. A lot of designs I see are so streamlined and only work in one way. This, again, takes very much things in the old classic way. It will create sort of written inventory files for things like Ansible. All the configurations for Terraform and the state files are separated and isolated. So you can just jump into the backend Docker container, change what you need to, and rerun it, and it'll work. So once it goes through the Terraform kind of apply status, all the directories are being created. It will then start querying Tailscale API. And what it'll do here is then obviously create the tagged project groups I mentioned with the ACLs, set up the rules for that based on its templates, and then it'll also sit there and just wait for this information to come back, and then populate the private Tailscale IP addresses into the database, so now you know, and the portal knows, where all your resources are, and generate your Ansible inventory files. So now you've got all your on-disk information, you've got your Ansible file, inventory files all built, your infrastructure stood up. You now go through the final stage, which will be the Ansible configuration. And again, this just takes a playbook. You can have as many playbooks for team servers as you want, so you can keep up with all the latest hotness and have all the best C2s with all your playbooks, no problem. It also supports just raw variable input through the form. So Ansible runner will just allow you to input whatever amount of variables you want in a kind of, key and value pair. So if you are using your own playbooks and you want to import them, you can update the front-end forms to take in whatever variables you want, pass it to Ansible runner, your playbooks will have access to them, and it's good to go. And again, that's all stored in the database, so you don't need to redo it, it's just there. The playbook will then run, configure your device, and at that stage you have a complete project. So we'll have a look at how that actually looks in practice when we get going. As I mentioned, adding new modules and new features is pretty straightforward. Ansible templates, you follow a module name, for example, team servers. Assets will be files, things that need to be moved around by your playbooks and be made available, and you just put in as many playbooks as you want. Easy as that. You want to add a new playbook, just put it in the folder. Same goes for new modules within Terraform as well. You just add in new modules, ensure you update a module load template from the template that's already available to you, and again, you'll have new modules. There are custom logic around certain things, like there's malleable profile parsing and things like that happen depending on what module types you're using. So there's like specialist modules with its own logic, but if you want to just add your own raw module, you can. Again, try to keep it really simple, just put files in the right places, name them right, you're good to go. Demo time. So we'll have a quick look at the project. So it's all, as I mentioned, like kind of web generated. So everything's dynamically added, and everything stems from projects. I don't know why I'm looking up there, I've got it right in front of my face. So once a new project's created, you can see there's a number of different kind of pieces of information we go through. Again, this can all be driven by the API, so there's no need to manually go in and create projects. So for example, we use Pipedrive, so our upstream process would be, a job's confirmed, it's booked, that automatically raises a project, you can assign it to a lead, they get an email, you go and you build your infrastructure. We have separate areas like project IOCs and op logs, which we'll have a look at when we get a build going. End dates, notes, like full WYSIWYG support pretty much throughout. And as I mentioned, like projects are the key. Everything stems off a project and is pretty much assigned to that. We can also have things like tasks, but again, we'll circle back around as we get time. But infrastructure is kind of the primary area we'll pay attention to today. So you can see there's already a project deployed here, which has a number of resources. So this has like stage 1. It's got an Nginx HTTPS redirector, which is linked to that stage 1. We've also got a GoFish server and a phishing redirect server. So you can name the type name to put whatever you want, so give it custom names so you know what's going on. Platforms and its status and everything, as I say, it's tracked through. You can see domain names are also attached and picked up along with tail-scale private IPs, public IPs, etc. And there's also build terminals, which is probably horrendously formatted because Terraform loves to add colors, and I haven't filtered it all out. But you can see all the back-end stuff as it's going through. So adding the keys, builds. You also get, if we keep scrolling, over the million builds I've done over the last few days, making sure nothing breaks. You can also see things like the Ansible outputs as well for the playbooks as they go through. So that's available again in the portal without having to go and find it yourself or get onto the actual resources. But what we'll do is we'll just quickly build something on the demo project. We'll just build something nice and easy. So we'll go for a Nginx server. We'll build it on, in fact, actually, we'll just add another domain that I purchased yesterday, if this works. Like my heart is fully in the hands of the demo god. So there you go. Again, this dynamically pulls everything from Route 53. So now DMX33F has been added. So we can go back to infrastructure, add a new build, select the project. Again, we'll go under AWS, we'll go for Nginx, we'll select the DNS domain we want to use, and we'll call this one reader.dmx33f.com, and we'll just call this one demo reader. And we'll hit go. So that's now queued. Effectively, the database has been populated, that's ready to go. What we'll now add for that as well, why not? We'll go for a phishing server. Again, we'll do on that. We'll call it mail.dmx33f.com, and we'll just call this GoFish. And again, add that. That's now ready to go. So now we can just click prepare, and as I mentioned, like during the process, that's going to initialize Terraform, initialize all the directories, build everything, and then we can just work through the build steps as we go. So the first initialization takes a little bit of time because it has to load the Terraform provider and do all that kind of good stuff, but after that, it's a fairly straightforward process. Again, we don't have to config Ansible at this point. We can do it later, we can do it at the beginning, but we'll do that in a sec. This shouldn't take too long, he says. Hopefully, everyone's staring at a spinning thing. There we go. So that's now updated to planned. And what we'll do now is go and configure these. So we'll start with GoFish, and we'll just do a clean GoFish redirector. So again, this is it's going to be any playbook you want. You can customize them however you want. So this one, for example, is just going to spin up GoFish, going to strip most of the indicators via its Docker deployment, and then also with the redirector playbook, is going to lock down sort of 443 and internet ports, so it only goes through the redirector. So with that set, you can now see that's updated to configured, and we'll configure the redirector. And again, you get linked resources, so it says redirector C2, but these can be the phishing servers or C2s, and it'll automatically populate the backend Nginx configurations to make sure the right ports go to the right tailscale server IPs, and you're kind of good to go. So we'll do a redirector on here, so we'll go for dscott.com. So basically, covert redirect URLs, so anything that doesn't match any of the rules within our Nginx config is going to be automatically redirected. And we'll hit build on that. So that will build everything in that project group. And while that builds, because that will take a little bit of time, we'll go have a look around some of the other kind of project areas. So one of the things I said I wanted to do was kind of unify as much information. So things like managing DNS records can be fully done within the portal. So we can do automatic mailgun registration. So click a button, you're automatically registered with a mailgun, everything's done, everything's set up, and the domain's added. You can then just go add your SMTP user, you're good to go, phishing, everything else like that. We can add custom records directly. We can do reputation checks. So you can see this hooks into VirusTotal. These can be run as part of a cron job or independently. So this is probably quite similar to anyone who uses Ghostwriter. They have like a DNS or a domain name kind of register and management platform. And that's where I kind of got the inspiration from that. This, again, is also showing that Terraform's running. There's a single backend queue at the moment until I got it working. So if you're running a job and a Terraform job's running, all other jobs that rely on Terraform check that queue. So we can't do something like an incubation domain at the moment. But what we have here usually, which we'll click, which I'll come back to, we can deploy a domain based on categories, either finance, health, or technology. And it will deploy effectively a dummy website, dummy domain that you can leave up to age and make your domain look legitimate for like a period of time, which is pretty handy. Recent features as well we've added is project IOCs as well. So again, this is all API driven. So we have ingesters that we can fire files into or point at file paths. It will go through and add all the file hashes for the files you want to put in there. We can also go through and add manual project IOCs, things like registry keys, service names, user agents, stuff like that we can then export and put into our reporting. Op logs are pretty new. I think I finished it this week. I think it's still in my features to do, but I did it. So, for example, this is working at the moment with Stage 1 and Cobalt, so it'll automatically parse logs as they're created and fire them to the API, so we can see like when a new beacon comes in. We can also see when like certain commands are run, we get the output for them. And then they're also automatically categorized based on their TTP and what the command is that's run, based on a database, and that's populated. We can export that directly into our reporting platform or provide it to the blue team so they can see that full timeline of activity of what we're doing. So yeah, that's like I said, that's one of my key ideas. When I say unified red team automation, it really is to go back to like kind of like 5-year ago vibe of like single pane of glass, I guess would be the cliche term, of bringing as much information together so you can make like good decisions as an operator, good decisions as a lead, and see what's going on across your entire team. So let's check back in and see how this is running. So the job has finished. You can see the tailscale IPs have been updated. There's public IPs for both resources, as by default the mail templates automatically sets up a public IP. But now the final step would just be to run playbooks. So again, we'll hit run, maybe. I just can't click. If in doubt. So configured, built. Yep. Now click is not working. Demo gods, come on. Why you do this to me? Quick jump over. Cannot process mal profile. It's because there is no mal profile, that's probably why. Fat fingers, never mind. Phishing reader copy, so there we go. So if you have a malleable profile playbook and it detects that you're using a malleable profile and there's a stage 1 or a Cobalt Strike malleable profile attached, it will effectively parse it for you and populate that into the Nginx config. So you have everything ready to go for you and it should all be set up. So in theory now, that still doesn't run. Oh, it does. There we go. Hey. So run playbook will now run. It will go through and do that. So you can see again on the back end, if you have a look, like it will set up the Nginx phishing server, redirectors, all of that stuff. So we can check in on how that's going, but it seems to be ticking along quite happily. One other thing we've added recently, and again is part of ongoing features, threat groups, emulation plans, and op vaults. So threat groups, for example, we can import direct sticks information, parse it, and have groups. So we can edit TTPs, threat profiles, and eventually the plan is to have built emulation plans that we can import directly into Vector for purple teaming. But that's still kind of in progress. Another idea, which again, I have to give a bit of credit to the Outflank guys for this, we kind of got inspiration from using OST. So they have a way of sharing approaches and recipes effectively within their platform for different users. So one thing we've now included is a kind of an op vault. So this allows us to parse various tools, import their Yara rules, which will then eventually be applied to CI/CD pipelines as tools are built. We can also pull out their detection rules. So this, for example, is using Elastic, so it's their publicly available rules. And we can add kind of bypass guidance. So if we've seen certain rules or certain detections during engagements, us as an operator can come in for the next person to say, look, if you're operating against Elastic, consider taking this particular steps to avoid this. We've seen this being a detection. Use X, Y, and Z repo, blah, blah, blah. Also, things like operational considerations can be added as well. So if you're operating against Elastic EDR, don't use run DLL, use unicorn.dll, etc. So this is something we're hoping to kind of build out over time as we engage in more and more as we do more and more engagements. We learn more and more about different EDRs, and we have somewhere to store that information. So yeah, that's something quite cool that we added recently. We'll see if this playbook's still running. Still is, of course. So GoFish is still installing. It's installing Go, which will probably take forever. But we can have a look at some of the other ones. So you can see kind of tail-scale IPs here, for example, for stage 1. So if you go have a look, 174. I shall show the APIs. So Ninja API, for those who haven't used it, is quite interesting. It has all the features, like I said, a fast API, so you get automatic API documentation. So everything's generated as you go through. You don't need to mess around with any of that. And like I said, I've tried to kind of keep everything API-driven as much as possible. And this just allows us to use it in as many different ways as possible. Things like the op log and like Yara parsers and Yara importers are much easier when you have an API to work with. So I didn't think, actually, I'd be stood around waiting in all my demos, but there we go. One of the other things we can quickly do is to just show you this, if it works. So again, this is a brand new domain. You can see that these new records have been added. We should also be able to just hit Mailgun and hope nothing goes wrong on the back end. And this will now go off to query Mailgun. We hit refresh again, and we see that all of those MX records, all of the NS records, the C names, everything have been added. So, like I said, this domain is now fully configured to be used with Mailgun. The other things we can do is also assign domain names to certain projects. So we know when a domain name's in use, add notes for things to ensure other teams aren't using it for phishing, if it's reserved for red teaming or something else. But that's pretty much how we designed it, so it can be used by any member of the team. You can be a seasoned red teamer and jump in and deploy your infrastructure, or just need to do a quick phishing assessment. It just takes so long. Building GoFish from source. What a time. Stand around. Everyone spends all their life just staring at spinny wheels. But we'll show you one of the other redirectors as well. So if we have a look at stage 1, again, once an operator's joined to their network, like we can quickly jump into any of the back-end stage 1s, if that API, if the IP is even correct, 174.777. 174.77.70. So you can see this dives now directly into our stage 1 instance, and again, this is all private, it's all self-contained. There's no public ports exposed, there's no need to risk anyone else being able to get access to our C2 infrastructure. Even the AWS instances themselves can't talk to each other. It all only happens over Tailscale. So there we go. IP table is ticking through now. Update config files. This is the slowest playbook deploy I've ever done. And then we start GoFish again now. So this should be the final task, he says. And what we also do here at the last stage is to cat the login credentials, so they're available for certain things within the actual portal themselves. So now that job's been completed, if you need to then sign into the GoFish instance, for example, that we've got, we can scroll down through here, hit refresh, scroll down through here, and we can go find the password and username. So you can just literally grab out the admin password. We'll go grab the IP as well. GoFish. So now this has all been built on the fly here now. Yes. So you can see in kind of terms of deployments, like in preparation for things like our assumed breach assessments, our deployment times have gone from like having to mess around for a sort of day to get infrastructure up and running. We can get payloads up and running and be testing payloads within 20 minutes, half an hour. So it's made like a hell of a difference in terms of deployment times. Look back in here, and that's all working, he says. One other thing we can just quickly do is just go and make sure and verify that the redirector for our domain is also bouncing traffic. So hopefully if we go here, we should get redirected to ZFCOM. And we do. So again, that's covert, that's hidden. It's got private location files for certain areas to actually allow traffic through to the GoFish instance, and GoFish is up and running and ready. So a bit slower than I planned, probably over a hotspot, but that's pretty much the end-to-end process of deploying infrastructure. And you can just keep adding more and more resources up here, for example. You see in the top group, there's 4 different examples of different resources. We can just keep piling different resources on top of each other, configuring them and deploying them, and they will just work. They won't interfere with other existing deployments. Everything's segregated from each other, and as I keep saying, it just works. So the feature roadmap, what's coming up, is oplog, which is now in there, but the emulation builder for indices for vector will also be added in soon. LLM integration as well to allow us to query data that's there. It's particularly helpful now that you can tag a project to using a certain EDR provider and also have your opvault that you can go through and gather all that information. CI/CD pipelines, again, to integrate with Yara and build toolkits for each project. So if you have a project, you can have an approved toolkit based on the provider you're using or going up against, and then expanding those project build queues out to, rather than being one over the whole platform, it's one per project, so you can do multiple builds at the same time. And this week, there will be a fast API proof of concept for the kind of original version that started it all. So it'll allow you to build infrastructure over just a basic API. There's no back-end database or interconnectivity of the resources, but you can kind of check out my spaghetti code and see what I've done in terms of moving templates around and working with it. Toward the end of the year, I'm going to release the infrastructure and project module, so you'll be able to add projects and release infrastructure for it. And then in the future, once all the features are complete, I haven't really thought that far, but at the moment it's going to remain sort of closed source with more and more features added to the public source version as we go forward. So yeah, thank you for listening to me bang on about infrastructure.